In this chapter, we're going to look at types of mixtures. And the first type of mixture we're going to look at is a solution. Okay, and solutions are homogeneous mixtures. Remember from way back in the beginning of the year, that means that they have no distinct particles. Okay, there are many different types of solutions. Solutions have two parts. They have a solute, which is what's being dissolved, or in the smaller amount. And then you have a solvent, which is the one doing the dissolving. It's in the larger amount. Now, solutions are not just liquid form. You can have gas solutions, solid solutions, or liquid solutions. You can have alloys, which are solid solutions. You can have air, which is a gas solution. There can't be distinct particles. The next type of mixture we're going to look at is going to be a suspension. Okay, suspensions are not homogeneous mixtures. These are heterogeneous mixtures. Okay, where you have distinct particles or layers. A suspension is going to be something where if it's left alone, particles will settle out. And they settle out into like distinct layers. So a good example here would be something like river water. Okay, so these are going to have fairly large particles. So we have solutions, which are homogeneous mixtures, which are going to have solute and solvent. You have suspensions there, which are heterogeneous mixtures, where if it's left alone, it'll settle out. So we have large particles. So we kind of have no particles that you can see, and large particles. And kind of in the middle, you have what's called a colloid. So colloids are where you have intermediate sized particles. These are not homogeneous solutions, they are heterogeneous. Okay, these particles do not settle out. So they're not that large, but they are big enough that they are not actually a solution. Colloids actually don't settle out because you end up having particles that are kind of connected to or attracted to the solvent, and so they don't settle out because they're actually attracted to the solvent itself. Usually they are polar mixtures. In colloids, there are lots of examples of colloids. The best one is probably milk or fog. Okay, colloids are hard to kind of tell whether it's a colloid or not. So all colloids display the Tyndall effect. It's going to be where if you shine a light through it, it will scatter the light. So that's kind of like why if you turn your headlights on at night when it's foggy, okay, or the high beams, you'll see all those particles that go through. Your light kind of gets bounced off of all of that. You can kind of see through, but you still see the particles. That's the Tyndall effect. Fog is a colloid, okay? And colloids are still heterogeneous mixtures. They're just kind of not as large of particles as a suspension, okay? Now that we've got those main types of mixtures, okay, now we're going to look at whether something is soluble or not, and solubility. Remember back to what solubility means. Solubility means that it is the ability to dissolve. So for things to dissolve and become a solution, you have to have the ability to dissolve in that solvent. The last thing here is miscible and immiscible, and this deals pretty much with solutions. Okay, things that are miscible are said to mix in any amount. Whatever it is, those two things will always mix. And when we're looking at those, we're tending to looking at two solutions. So I can always dissolve tea and lemonade. Those are miscible. Something that is immiscible, those are going to be won't mix. So they might look like they will if you shake it up, but then they settle out right away. Oil and vinegar is a good example. And again, these have to be your two solutions, or two liquids. So there's a little bit about the different types of mixtures.